Hello everybody and welcome back. Another root beer video for your enjoyment. We're going to continue on with the 2019 ninth grade level Friar contest put out by the University of Waterloo. We're going to be looking at question number 2 today. So how about we take a look at the contest paper. Alright, question number 2. If A is greater than 0 and B is greater than 0, a new operation, upside down triangle, which I believe in higher math is called a nabla, but that's neither here nor there right now. So upside down triangle is defined as follows. A upside down triangle B is the same as A plus B over 1 plus A plus B, or plus A times B. For example, 3 upside down triangle 6 is the same as 3 plus 6 over 1 plus 3 times 6, so that's 9 over 1 plus 18, so 9 over 19. Alright, A part. Calculate 2 triangle 5. So this should be fairly simple. 2 triangle 5. What is that? So that's 2 plus 5 is on the top, over 1 plus 2 times 5. That's 7 over 1 plus 10, which is 7 over 11. It's a nice little fraction. Kind of makes me want to go out and get a Slurpee. But 7 over 11, we can't reduce that anymore. It's already in reduced form, so we're done. 7 over 11 is 2 triangle 5. So that's A part. A part just getting us used to the problem, used to our new operation that we've defined. More stuff will come later. So B part. Calculate 1 triangle 2, and then triangle that with 3. Okay. So we're getting a bit more adventurous with our new operation. We're now going to introduce brackets with it. So we want 1 triangle 2, and then triangle that with 3. Well, even though this isn't quite order of operations, I mean, there's no triangle symbol in PEMDAS, BEDMAS, PEMSA. There's no triangle symbol in the order of operations. We still always do brackets first. So we keep those brackets around there until we have just a solid number that we can work with. And we keep this triangle 3 out here. We don't know what to do with it yet. So we get 3 over 1 plus 2 is, well, that's 3. 3 over 3, that's going to be 1. So now we're left with 1 triangle 3. Well, hey, we can do that. I don't need those brackets either. So 1 triangle 3. Well, what does triangle mean? We do 1 plus 3 over 1 plus 1 times 3, which is equal to 4. Over 1 plus 3, which is 4 over 4, which is equal to 1. So I'm guessing that 1 triangled with anything is probably going to end up being 1, which is pretty cool. It certainly looks like that's what's going on. One might notice that A triangle B is going to be B triangle A. I don't know if that's relevant, but that's something that if you can't see that, try and prove it. Or if you think you see it, try and prove it. Yeah, so 1 kind of acts like a 0 here. Nifty. But we were just asked for 1 triangle 2 and then triangle 3. Well, we got 1 right back out. Very nice. If 2 triangle x is 5 over 7, what's the value of x? Okay, so 2 triangle x will have a fraction that's got x's on the numerator, in the numerator and the denominator, and we'll set that equal to 5 over 7. And hopefully we can figure out and get an equation just in x that we can solve. Okay. So 5 over 7 is 2 triangle x. Well, what's 2 triangle x? Well, that's 2 plus x over 1 plus 2x. Okay, so if we want to solve these, we multiply through by 7 times 1 plus 2x, so we get the 1 plus 2x on this side. 7 comes up here on this side. All right, basic manipulation of fractions. This should be old hat. If you need help with fractions, there's plenty of resources online. There really are. Fractions are something that, for a grade 9 level contest, you should be comfortable with. So multiply that 5 through. 5 times 1 is 5. 5 times 2 plus x, or 2 times x is going to be 10x. 7 times 2, that's 14. Plus 7 times x, that's 7x. Now we want to group like terms. So let's get all our numbers on this side, on the right-hand side, and all our x things in x on the other side. So 10x minus 7x is equal to 14 minus 5. So that's 3x is equal to 9. X is going to be 9 divided by 3, which is 3. Right? To cancel out, if we have 3x is equal to 9, and we just want x, we have to divide by 3 on both sides to cancel out the 3 that's with the x. All right. So 2 triangle 3 gives us 5 over 7. Okay, so let's take a look at the next part. Alright, D. For some values of x and y, the value of x triangle y is equal to x plus y over 17. So there's a 17 there, and there's a 17 in our previous question. You might find a lot of 17s cropping up on fryers. I know one of the guys who helps make up the fryer, he loves the number 17. So you see a 17 on the fryer, odds are he made that question, or he had some input on it. Alright, so x triangle y is equal to x plus y over 17. Determine all possible ordered pairs of positive integers x and y for which this is true. Okay. So x triangle y is supposed to be x plus y over 17. Actually, you know what? There's a better way to write this so it flows more naturally. We are told that x plus y over 17 is the same thing as x triangle y. But we have a formula for x triangle y. It's x plus y over 1 plus xy. Okay? So now, just as we did before, we'll take this stuff and bring it over here, and this stuff and bring it over here. We'll have so 1 plus xy, x plus y, is equal to 17 x plus y. Okay. So I notice I have an x plus y on both sides. If it's not 0, I can divide by it. Now, if we go back and check the question, it's that A and B, so the inputs for this operation have to be greater than 0. And we're actually told all ordered pairs of positive integers x and y. So x and y are greater than 0. So x plus y is definitely not 0. So then we know 1 plus xy is going to be equal to 17. And we can bring this 1 over to the other side and get 16. Now, the question asked us x and y as positive integers. So we're looking for x and y positive integers, both of them multiplied to give us 16. So x and y, we could have 16 and 1, could have 8 and 2, could have 4 and 4, could have 2 and 8, and lastly we could have 1 and 16. Okay? So were we asked how many? No, we were determined all possible ordered pairs, and notice that we do have ordered pairs. We have 2 and 8 here, but we also have 8 and 2, reflecting that x could be 8 or x could be 2. So we get 5 ordered pairs here, 5 different factors of 16 that x can be, and then y just makes up the difference. So that gives us all the possible x and y's. And if we wanted to, we could go back and use our formula for x triangle y with each of these and show that it does work. But we don't need to. The math speaks for itself. And that about covers it for question number 2. So thank you for joining me for this portion of the Friar 2009 paper. And I'll see you guys in the next video.